Okay, so we're starting again. Now, as someone said there's a lot in it. Yes, there is a lot in it. Do you need to know all of this? I honestly don't know. I'm presuming you do. The unfortunate thing. Um, as I say, I haven't looked at the exam questions yet, so but I'm presuming when it's in the book, it means you have to know it. So, yeah, unfortunately. So find any returns an optional. Okay, so that means uh, you can use all the methods of the optional class method. So you can use or else get, you can use is present, you can use dot get. Okay, now find first. Oh, thanks, Lisa. Find first, as far as I can see. Now, find any. If there is something in the stream, it'll find the first element in the stream. Okay? Find first, as far as I can see, does the exact same thing. Now, as far as I know, I can't see the difference between find first and find any. Right? I've messed around with it a bit there this morning, and I couldn't find any difference between find first and find any. So it basically does the same thing. So I'll quickly do something here. So I created returns an optional, and as far as I can see, it's the same as find any. Okay. Now, so I've created an array list of animals. Now I'm going to populate this array list of animals via stream. So I've got stream.generate. Oh shit. That's gone very blue now. I look really strange. I look sick. I do, yeah. The normal even. Okay. She wasn't blue, was she? She was green. Actually, I'm green there. Fucking hell. I fly, my pretties, fly. Anyway, stream.generate. So we're going to generate just animals. And we're going to limit it to 5. And we're going to do a for each. Oops. Dot for each. And we're going to, what we're going to do inside the for each, I'll put it on a separate line. So for each takes a consumer object. So it's going to take the animal that's produced, the 5 animal that's produced. And it's going to print off first animal is added to the array list. So inside of here, I'm going to go list animal dot add a. Okay. So again, you can do that over those lines. So this is what generates the stream. This limits it to 5, and then we have a for each. Generate takes a supplier. For each takes a consumer. Limit takes an int. Okay. This guy returns a stream. Limit returns a stream. For each returns void. Okay. And inside the for each, it's going to print off the animal. Then it's going to add that animal to an array list. So you end up with an array list of 5 animals. Yes? Okay. Now, this is the list of animals. That'll print it off. Okay. Now, find first, to show you it operates the exact same way, I go list animal dot stream dot Find first. Now, if it returns the same type, see, I can't see what difference it does. And what that's going to do, it's going to find the first animal if it exists. Find any also does the same thing. Now, there probably is a difference when it comes to parallel streams. Okay, that's the difference. All right, but we don't have to cover that. So find first. If there is no first element, or else get, I'm going to say null. Okay. So what's that going to do? That's going to find the first animal. If the first, and which is going to return an optional. Okay. If there is no value, if there is no first animal, then it's going to return null. There is an animal, so that's going to print out null. Okay. Find first, same as find any. Is that okay? Right. Now, so we're getting all of those guys. So we're going to go, this is static void ex7. Age is equal to 0, name is equal to null. Okay? Because I haven't given any name to the animal. Okay? Now, if I gave it, so I haven't given it an age, so the default value is going to be 0. I haven't given a name, so the default name is going to be null. Okay? Now, so find first is going to get the very first animal, which is that guy. Okay, that's what's produced. Now, EX7. So, these are the 3 different terminal operations. So, the first one is, so, right out, so terminal operations, any match, all match, none match. Okay, so here are the method signatures of each one of them. The first one is any match. So any match is Boolean any match. It returns or takes predicate. Now, that means it returns a Boolean, it takes a predicate. Now, this guy here, so let's say if it's an animal, okay? Let's say you've determined your predicate to be of type animal. That means it can take animals or a superclass of animal, okay? But if it's, now an animal can be a dog or a cat or whatever, okay? So predicate takes, let's say, an animal, all right? So what you're doing is you're testing some object for something. Okay, so you're testing your stream to see is there an object in that stream that matches something you're testing for. Okay, that's the any match one. Then you have the all match, which looks like this, which is Boolean all match, and again it takes a predicate. So it takes a predicate. Simple and that. Okay. And the last one then is none match, which is exactly the same. Takes a predicate. So this is probably one of the easier ones. Now, as to what each one of them does. Okay, so any match. If any item in a stream returns true, so if any item in the stream, sorry, that's wrong, this stream matches what this predicate is looking for, so if we're looking for a particular dog, okay, we're looking to see, is there any dog in this list that has a nail spot? You could have 1,000 spots in your list of 1,000,000 dogs, so it's only going to return true. So you're just asking, does a dog spot exist in this string? Okay. So this one, if all items in a stream matches what this predicate is looking for, this will return true. So this one, i.e., are all dogs in the stream called spot. Okay, so any match is looking for, is there any dog in this list called spot? All match is looking for, are all dogs in the stream called spot? And none match then is, guess what that is? If no items in a stream matches what this predicate is looking for. This. Well, you're looking to see, is that all that's in it? Okay, so you could have 100 dogs, and are all the dogs called spot? Okay, now it's not looking for a particular object, it's looking for some condition. So if no items in the stream matches what the predicate is looking for, return true, i.e., is there no dog called spot in the stream? Now, I think those methods, I don't think we did them in the collection. We're dealing with collections. I think that's one part we didn't do, was any match, all match, and none match. I think there's methods called that as well when we're dealing with collections. Right. No, they're not. They're separate. Okay. So we are going to create a couple of streams. Okay. And we're going to give them names. So first thing, this is a list of strings. I'm going to call list is equal to arrays dot as list monkey. I'm going to put in the number 2. I'm going to put in the word chimp. And then I'm going to go stream, string, and this is going to be infinite, it's called. And it's going to be equal to stream dot generate. It's going to generate an infinite supply of the word chimp. Okay, that's going to produce an infinite amount of strings of the word chimp. And the last one, stream of strings, and I'm going to call it streams, is equal to stream dot of, it's going to be the same as this, Right. So we're going to create a predicate. Now, predicate is something that takes an object of particular type and returns either true or false. Okay. So I am going to be using any match, all match, and none match on these three streams here. Right, so we're going to create a predicate. So rather than having to type this out each time, we're going to use this predicate numerous times. All right, so this is going to be a predicate that takes in a string. We're going to call it pred is equal to. So this is a predicate that takes in a string, which we're going to call x, and then we are going to go character dot okay. So I need to import that guy. All right, now, so what is this doing? This is going to check the first right. This is going no. So here, I'll explain what we're doing here. Now, right. So character is letter. What that does is that checks a particular character to see is it a letter. Okay. Now, so if it was checking this one, it will return. And returns true or false. Okay. So what it's going to do is going to check each one of those. Okay. So if it was checking monkey, that would return true. If it was checking this guy here, because M is a character. If it was checking this one here, that would return false because 2 is not a letter. Yes? And the third one here, chimp, C is a letter. Is that okay? Right. Now, so what the predicate does is it's going to check each one of those. So we're going to use this predicate with all match, none match, and any match. Yes? Okay. Scroll down the screen. So the first one we're going to do is well, I'll create the streams as I'm going along. So I'm going to go print it out. Okay. I am going to go list dot stream dot. First one I'm going to use is all match, and I'm going to use the predicate. Okay. Now that's checking to see do each one of the strings, do they all begin with a character? Okay, monkey does, chimp does, that guy doesn't though. So that's going to return false. Okay, so do you see what you can do with all match? You can check all of your strings for something. Okay, you can check all of your strings for something. All right, so you can see, does this list meet certain criteria? If it doesn't, well, then do something else with it. All right, so what are we doing here? So this checks the strings monkey, 2, and chimp to see do they all begin with a character. They don't, so this will return false. Okay, EX7. I'm going to go to here. Examples are EX7. False. Okay, fine. I'm going to do the same again with, yeah, I'm going to do that in a minute. Okay, now I'm going to do the next one. I'm going to do streams. Now streams is monkey 2 and chimp. Streams dot non match. Right. So what's that going to do? That they're going to check to see do none. This checks the strings monkey, 2, and chimp to see do they all not begin with a character. Okay, that's not true because both monkey and chimp do begin with the character. So both monkey and chimp do begin with a character. So this also returns false. Okay, so put it here. Also false. Okay. Now, streams is closed at that point. Okay. Streams can no longer be operated on. Do you understand that? So this is false. This is false. And streams is now closed. Okay. So you can't operate in streams anymore. You have to redefine it again. Okay. But I'm not going to do that. I'm going to use the list again. So I'm going to go list dot stream. Oops. Dot any match. Right. Okay. So what does this do? I'll put this in the print statement. So this checks the strings monkey to chimp to see do any of the strings begin with a character. Both monkey and chimp do. So this will return true. Okay. All right. double semicolon doesn't matter actually. It's just a blank line. That's what double semicolon is. Now, now, so what can we use with an infinite string? Okay. So we have an infinite stream up here. So that's going to be constantly producing, try and get some one page. Okay, right. So we have an infinite stream here, and it's going to be producing an infinite amount of the word chimp. Okay, could we use all match with an infinite stream? Yes or no? No, because you can't. Because it's going to keep. So what's going to happen when you use all match with an infinite stream? It's going to keep on going. Okay. Similarly, you can't use none match. Okay. You can't use none match. Why can't you use none match? Come back to that in a minute. Yeah, it's infinite, so I never finish. It doesn't know. Yeah, but the thing is, none match. If the first one does match, then that can't be true. Do you know what I'm saying? I'll come back to that one. Yeah, but the thing is, any match works with it. Any match does work with an infinite string. Okay, so I am going to use this guy here. Okay, so I am going to go infinite dot any match spread. Okay, now this should return true. As I hopefully. Yep. Okay. Let's put in a little print statement for it here. So yeah, you can use any match with an infinite stream. Okay. Let's redefine it again. So you can't use all match. So if I go infinite dot all match spread, now it looks like nothing is happening there, but look at the little red boy. Okay, so that means it spends an infinite amount of time checking all the numbers that are created, or checking all the strings that are being created. All right, so click that off. So I'm going to put it in here. So this is going to be true. Now, here's the thing about any match, all right? Yeah, I'll come back to that in a second. Okay, it'll only work under certain circumstances. So all match. So put in here. Can't answer this question as this would go on for infinity. So we have to kill the process. Now, so you can use none match on it. All right, you can use none match on it. So I'm going to go this one here. So if I go infinite dot none match pred, I'm going to put that in the print statement. Okay. Now, here's the thing, right? Let's see. Both any match and none match won't be infinite as long as it's true. Okay? If it's producing streams that are going to be false, it's going to be infinite. Now, it's going to keep on going. Now, what do you mean by that? I'm going to change the predicate to, where am I? Fuck is it? Extras. Right. But here's the thing, right? So, extras. So all match, yes. None match can work. Okay. Any match. That's still gonna work. I'm gonna change the list as well. Right, so I'm gonna change this guy. Say list is equal to, now I'm going to change this as well. I can't add to it by this guy, so I have to change this lad up here. So I change this new array list, and then I go list is equal to list dot, oh sorry, list dot add all arrays as list, and it's going to be monkey 2 and chimp. Okay, that's fine. So I'm going to go down here, change that list is going to be equal to the list are clear. That's got rid of all our characters. List dot add all and arrays as list. I'm going to add only numerics 2, 3, 4. I'm going to take out that guy. Now, if I base a stream on this list, so yes, you can use any match on this list that contains monkey 2 and chimp. Okay. Yes, you can use none match. Okay. Now, learn one. Hold on a minute. It's infinite. I need to clear. Bollocks. So is equal to stream dot. So I'm going to create an infinite amount of streams. That's the number 22. 2. Okay. Now, so this is an infinite amount of streams that uses the number 2. Yes? Right. So I've changed it. Now, if I come along here, and so I'm checking to see, so this produces an infinite amount of streams, or an infinite amount of strings that contains just a number and nothing else. Okay, so if I go infinite dot any match predicate pred, now, so that's checking to see does any of the strings that's produced, does it begin with a character? Okay, what happens when I do this? That's going to be infinite. You see why? Okay, I'll stop it. Right, what's happening is, in that case, this produces an infinite amount of strings that contain nothing but 2. Goes on forever, right? So, infinite, checking to see does any of the strings match the conditions. The conditions are, it's checking for, to see if the string have the first character, is it a letter? Okay, all it's doing is producing 2's. So it keeps checking the 2's forever and ever and ever. If it's not true, any match is going to go on forever. Okay, similarly, that I will take out that. I will go SYSO stream dot, so infinite dot none match pred. Okay, so that's going to check to see, so again that produces 2 2 2 2. So it's going to check forever to make sure that none of those strings contain a character as their first part of the string. So that's also going to run. Forever. Okay, so on an infinite stream, any match and none match only work as long as they return true. If they return false, if an infinite stream can return false, then none of these guys work on it. Okay, I'm afraid to say that looks like an exam question to me. All right, so this guy here, this will produce infinite amount of processing. Okay, sorry, go here. This produces an infinite amount of strings that contain the int 2. Okay, which when tested against our predicate, that checks to see if the first character is a letter. Testing against the predicate, that checks to see if This will produce infinite amount of strings contains them, which when tested against our predicate that checks to see if the first character will return false. Okay, and if any match or non-match can return false from a infinite stream, then this will continue on forever. Okay, it's not an infinite loop. I suppose you'd call it infinite processing time. Infinite processing. That's what I'd call it. So it keeps on checking to see, does the next one, oh, maybe the next one starts with the 2, it doesn't. Maybe the next one starts with the 2, it doesn't. Maybe the next one starts with 2, no, it doesn't. Okay? So both of these will produce a infinite processing. Okay? Whereas up here, infinite any match pred, that returns true. So if that returns true, it's not going to be infinite. This one here as well, none match pred true. That returns true, that means it's not going to be infinite. So yeah, it's because it returns false, it's infinite processing. Okay? Let's make sure. That's all there is really to those guys. Okay, so any match, none match, all match. Okay, there's nothing, I can't think of something more in it. There isn't. Okay, there's nothing else to those things. Okay, so I'm going to go on now, just to briefly show you. That's a predicate to check that your first character is a number. That's what that guy is. Okay, that's a predicate to check that the first character in your string is a number. Now, that could come in useful with GUIs. All right, that could be useful in GUIs. So, because as I said to you several times before, when you're doing GUIs, everything is saved as a string. So let's say you have a calculator. You're pressing the number 1. It's not the integer it becomes, it's the string 1. So you can imagine a stream that's producing strings, a calculator, whatever. You want to make sure that whatever you do with the GUI, it's always dealing with strings. All right, so you can imagine a situation. We can use that with GUIs. It's checking to see, is all the characters you're entered in, is the characters and not the A, or not B, or not C. Okay? Now, there is other ways of doing it. It's just one way of doing it. Now, we covered this one before, but I'm going to cover it again. Next one is toArray. So that is EX7. So I'm going to go to static void X8. So this is toArray. So now, so an example of that is, so I'm going to create a stream of strings, and I'm going to call it names. And I'm going to say stream dot of, I'm going to say Mary, Kate, Pat. So I'm going to create an array of strings. I'm going to call it name array. It's as simple as this. You go stream names dot to array. Hold on a minute now. What's wrong there? Why isn't it giving me? Right. Hold on a second here now. Names are too rich. Did not return. Let me just try this. Okay. Right. I'm going to come back to array because I didn't realize what it actually returns. It's returning an object. It's an array of objects. All right. It's an array of objects. So I do realize I haven't got it. I don't know how to actually change it to an array of strings. Okay. So I will come back to that. All right. But that's neither here nor there. I'm going to go to static void ex9. Now, we've done this one plenty of times. This one is for each. It's for each. Now, what does for each do? For each takes a, what do you call it again? I forget. Consumer, that's it. Okay, takes a consumer. Okay, so for each, a consumer, which a consumer takes a object and returns void. Okay, so for each takes a consumer takes an object and returns void. Right? So we're going to create a stream of strings. Or it can be a stream of anything. And I'm going to call it animal stream. And it's equal to stream.of. I'm going to say monkey, gorilla, bonobos, which are the second most promiscuous mammal. Guess what's the most promiscuous mammal? That's us. Okay? Alright, so I am going to create a list of strings, and I'm going to call this animals. Okay? Okay, now the list of strings, I call it animals, and I'm going to say new array list. I'll put in there, I don't have to, but I'll put it in to be. Now, simple way to populate this list with all those animals is quite simply like this. We'll go animal stream dot for each and we take in the stream and we add the string to our list. Okay, now, so that means we now have a list that contains a monkey, a gorilla, and bonobo. Now you can shorten this, all right? You can use the shortened version of this as well. So if I go, I have to redefine animal stream again. Redefine it again. And then I go animal stream dot for each. Now it takes consumer, so that means you can go animals add. Okay, so both of these do the same thing. Now you're going to end up with monkey, gorilla, bonobo, monkey, gorilla, bonobo. Yes? So you have a list that contains 6 strings. Monkey, gorilla, bonobo, monkey, gorilla, bonobo. All right? Now, just explain what's happening here. Now, a for each takes a consumer object. A consumer object is takes in an object and returns nothing. Okay, so you can do anything you want inside the lambda as long as it doesn't return anything. Okay, so here's taking the string, and inside the for each, this is our consumer that takes in the string, which is s, and then inside the consumer, it adds s to our list of strings called animals. Okay, now this is the shortened version of it down here. Okay, now, so animal streams dot for each, it knows that it takes consumer, so that means it has to take a string. Okay, so you can omit the s part. All right, now this has to be animals. Animals is an array list of strings. Okay, it's an array list of strings, so you can only add strings to it. So what does it know to do? It knows to do that the string I put in is going to be added to this list. So animals.add is exactly the same. It's doing the exactly same thing as that. Okay, to prove that it is, we should have now 6 strings in our array list. Okay, so if I print off, this is animals is, we should be getting monkey, gorilla, bonobo, monkey, gorilla, bonobo. So it's animals. And it's EX9. There it is. Monkey, gorilla, bonobo, monkey, gorilla, bonobo. Okay. Now you can do anything inside for each. All right. You can do anything inside for each. But you've got to remember, make sure your for each doesn't return anything. Okay. Make sure your for each doesn't return anything. So, for instance, I'm going to create a stream from this list. Okay. I'm going to create a stream from this list. So I can go stream, it's animals dot stream. That's not parallel stream. Dot stream dot str stream dot for each, And what do you want to do to each one of these strings? I'm going to, so this is a consumer, so it takes in a string, and we're going to put it over a few lines. So I'm going to say animal is plus s, and then I'm going to go animal lives in a plus s plus house. So that's going to be animal lives in a monkey house, animal lives in a gorilla house, animal lives in a bonobo house, animal lives in a monkey house, animal lives in a gorilla house, animal lives in a bonobo house. Okay? And you can go, you can put in the return as long as it's returning nothing. All right? You can put in a return as long as it's returning nothing. Because remember what return does, a return's primary function is not to return a value, it's to exit the method. Okay? So animals.stream.forEach, it's going to print off each animal, and then it's going to say animal lives in a monkey house, gorilla house, bonobo house, monkey house, gorilla house, bonobo house. There it is. All 6 of them there. Okay. Now, it's important to note that whereas for each, yes, they can access arrays. It can access arrays, it can access array lists. However, if your stream is based on an array or a list, all right, you can't access that list. What do you mean by that? I can't go animals.add s. Now, it might look like it works, but I should be getting concordant modification exception. Okay, so if your stream is based on a list, right, meaning animals.stream, it's very easy to produce a stream from any collection object. So if your stream is based on a collection object, you can't access the list by name, because you don't have to, is the first thing anyway. Because what are you doing in the for each here? You're accessing each one of the strings in that list. Okay, so you can't go animals.add. This leads to a concordant modification exception. Modification. Oh, jeez, there is a lot of shit to know on this, isn't there? Fucking hell. Okay, we'll have to devise some way of trying to remember the stuff that's important. I don't know how, but we'll have to think of some way. This leads to a concordant modification exception, as you can't access a collection object. Now, collection object is a list, a queue, or a set, as you can't access a collection object by name directly inside a string. Okay, so for each is the most likely place you would be accessing it. So this will lead, so concordant modification, now that's a lead to the runtime exception, to a runtime exception, concordant modification exception. Okay, now the reason you can't add to it is because you can be modifying the strings that's produced and adding to it at the same time. So it doesn't know what to do then. So you base a stream on 6 animals. All right. Now that means that's locked down. The stream is locked down. It's only got 6 animals. You can't then add another animal to it. Do you understand what I'm saying? So animals dot stream for each. For each looks at the animals, it sees that there's 6 strings in it. So that means that this stream then has 6 strings in it, and that's it. So you can't add anything to it. You can modify each one of the strings, but you can't add anything to it. Okay? Now, so just to point this out, and I'll even put it in block capitals in case there's any confusion. For each is not a loop. Okay, it's not a loop. Now, to make things even more confusing, in other programming languages, there is loops called for eaches. Okay, so there is no for each in Java. There is in other programming languages. Is there a for each loop in PHP? Can you remember? Is there? I think there is in Python. Is there? Yes, there is. So for each is not a loop in Java. It is in other languages. Now, it doesn't implement the iterable interface. Okay, so it doesn't have iterators either. All right, a stream can add to lists. It also can produce lists. All right, there's a method called collector, sorry, that produces lists, sets, queues. Okay, but streams themselves don't operate on loops. They're all about producing constant or infinite amounts of items. Okay, and when you do limit, all you're doing is you're taking the first 5 that are being produced. There is no counting mechanism going on. Well, it's counting the amount of streams that are created, but streams are just a way of creating objects. So streams have nothing to do with loops. They could be seen as an alternative to loops, but they're not loops in themselves. For each is not a loop in Java. It is another. So there are for each loops. So you notice with streams as well, you don't have to use incrementers. You don't have to go I plus plus or any that sort of thing. All right, don't need to do that. All right. Now there is, so this is for each ordered. Now for each ordered is for parallel streams. Now parallel streams are much faster than ordinary streams. Okay. So let's say we have uh, animals. That's parallel stream. Okay. Dot for each. And we just want to print them out. I'm going to put it in because I want to print off a little statement. And it's going to be not in order. There should be a print statement. Give me a second. Right. So this is for parallel stream. So animals dot parallel stream. Now we already know that the order of them is monkey, gorilla, bonobo. Okay, so it's the order is monkey, gorilla, bonobo. Okay, now that's if you print them off as an ordinary stream, right? However, if you do them as parallel streams, shit, I printed out in the right order. Let me see if I can get them in the wrong order. All right, so we can see it's printing off monkey, monkey, gorilla, bonobo, gorilla, bonobo. Okay, that's not the order. It should be monkey, gorilla, bonobo, monkey, gorilla, bonobo. Now, whereas parallel streams are much faster. Now, you can do anything with a parallel stream, you can do them with an ordinary stream. Okay, now, so parallel streams are much faster. Are much faster if the machine you're running your application on has multiple cores. Okay, it has more than one CPU. For instance, most phones now has got 2 or 3 cores. All right, and it can also utilize threads as well, as far as I know. Parallel streams can also utilize threads. So if you have 10 threads, you could have 10 parallel processes going at the one time. So you can increase your how fast something is done by a factor of 10, by factors of hundreds actually. Okay. Now the one problem with parallel streams is that it's concentrating on producing the strings. It doesn't take into account any sort of order, so it just spits them out. All right. So that guy there produces a parallel stream, which is fairly fast. Okay, so we'll say that's producing 1 billion strings. All right, and you're running on a machine that's got multiple cores, that's got multiple threads, so it runs like that. Now, but the billion strings it produces are all over the place. All right, because for each works for ordinary streams and parallel streams. Okay, now there is a method called for each ordered, and what that does is, so I'm going to call it here. So I'm going to go same thing again. Animals. Now animals is a list, so I can keep creating streams from it. Parallel stream. And I go for each ordered. And it's going to print them off. So S.
General Assistant, contact reception. General Assistant, contact reception, please. Thank you.
In order S. Now, what this does is, so this produces a parallel stream, we'll call it P1. Now, what for each order does is it converts a parallel stream to a stream. Now, in the process of doing that, from that point onwards, it's going to be treated as a stream. Okay, but here's the thing, up to that point, it's going to be treated as a parallel stream. So you can have all your heavy processing, you can have it as a parallel stream. And then you just go for each ordered. So it's only the last bit where it's treated as a stream. Okay, remember, so animals.parallel stream produces a parallel stream. For each ordered produces a stream, not a parallel stream. Okay, but beauty of that is that everything up to that point is going to be treated as a parallel stream. That's a terminal operator. It's going to cause, also you could have your code creating billions of objects, filtering out those billions of objects, limiting those billions of objects, doing all sorts of things with those billions of objects, doing it as a parallel stream, and it's only the last bit changes it to a stream. Now, if it's running a machine with only one core, and there is a way to utilize parallel streams with threads, I'm not too sure how to do it, but you can do it. Okay, so if you have something called a multi-threaded application run on a machine with multiple cores, it's going to fly along. Now, you might think, well, hold on a minute. Let's say those machines there only have one core, right? The thing is, most servers have multiple cores. I'm talking about CPUs, the brain. Most servers are going to have multiple cores. So if you have parallel streams run on a server, let's say Amazon servers or Microsoft servers, they're going to have multiple cores. So this software is always going to run a lot faster on servers. Because it doesn't matter what sort of app you're developing, you're going to have some software on. You can have nearly all your app on the server, and they just basically connect to the app and do their calculation. Or you can have the app on the phone. All right? If you have the app totally on the server, it's going to run faster. If you have a parallel stream. Now, parallel streams aren't really on the exam, but they operate. The main difference is they're much faster. That's provided the machine is faster. It's got more cores. But all the operations that operate on stream also work the same way on parallel stream. The only difference is that they're not in an order. If you want to order them, you have to use for each order. But as soon as you do that, it becomes a stream. Okay? Sorry? Yeah. So we can see that this one here. So this prints off not in order. They're mixed, yeah. So I'll run it. So I'll just say not sorted. Sorted. Now sorted should be printing off monkey, gorilla, bonobo. Okay, so I'll just write that down here. It's monkey, gorilla, bonobo. Okay, so I'm going to run it. Right, so not sorted. So we have monkey, gorilla, bonobo, bonobo, all over the shop. Okay, so for each ordered, monkey, gorilla, bonobo, monkey, gorilla, bonobo. Okay. It depends on how many cores you have on your machine. I think there's more than a. I'm not too sure how they're done here, but let's say if you've got two cores in a machine, I think that does translate to more than two streams. I don't exactly know how many transfers there. Now you can use these as well with threads. So if you've got a multi-threaded application running on a multi-core machine, then you're going to notice the application literally thousands of times faster. Literally thousands of times faster. All right. Yeah. Yeah, you can, but it's only going to use that one core. So parallel streams will use whatever's there. So, and by the way, you can use for each ordered on an ordinary stream as well, but it doesn't do anything different. There is some method that can identify. You mean to say from you want to identify that that's a parallel stream? Yeah. Oh, you mean to say you? Let's say you had two parallel streams that are creating another parallel stream. Yeah. Yeah. There is a way to find out. Um, yeah, there is a way to find out. Well, what you'd have to do, Kieran, there is you'd have to do something called peaking, right? And what peaking allows you to do, it allows you to look at what's produced without giving a final output. So peak will do everything a for each does, except it returns the stream. Okay, and that's an intermediate operation. So you can peak, it produces a new stream, and you can see if they're not in order, you can see that's a parallel stream. If they are in order, it's a stream. Now, what I mean in order, I mean the way they're taken from the list. So our list is made up of monkey, gorilla, bonobo. So if that's an ordered stream, they're going to be put in as monkey, gorilla, bonobo. If it's a parallel stream, they can be put in anyway. So, but there is a method that'll tell you whether they're parallel streams or not. I can't remember, but there is a method. Sorry? Um, but here's the thing is, you can use, so if it's an infinite stream, well, you can't base an infinite stream can't be created from an existing list or set, because you can't have an infinite set. So if you're doing that, you know that that's not infinite. Okay, but if you're using stream.generate and stream.iterate, then they could be infinite. And you can have a for each on those. That's just going to do it forever, whatever's inside the for each. Okay, maybe I should have said that. Okay, so just before I get to it here, if I go stream dot generate, and so it takes nothing and animal new, isn't it? So takes consumer, takes an animal, and prints out the animal. Now, that's generating an infinite amount of animals. Okay, and then it prints them all out. So that will go on forever. Okay, so for each can quite easily be called on an infinite stream. Okay, so I don't want that to happen. Take them out. So you can call a for each on an infinite stream. Now, I'd imagine that you can be producing objects for 15 minutes, or you can produce objects until the end of today, right? Instead of, yeah, you could generate animals as long as it keeps each time in the for each here. Inside the generate here, it's a while current time is before 12 o'clock tonight. Keep creating animals. Right? So that would be one way to create a shitload of objects. You'd have trillions of objects done. Okay? So generate is very, very flexible. It can be time based. It can you can set it up to run intermittently. Is it 3 o'clock yet or whatever? So you can call it for each and infinite stream, and it will keep going forever. Okay. Now, so for each ordered, it's for parallel streams. Now you can call for each ordered on a non-parallel stream, but it doesn't do anything different that for each does. So you can call for each ordered on a non-parallel stream, but it operates exactly the same as on a parallel stream. Now it's important to note here as well that so it's not for this one. Up to the for each ordered, ORDRE. Up to the for each ordered, this is a parallel stream with all the speed advantages, and from the for each ordered, it is now a non-parallel stream. So it doesn't make the whole lot of it a stream, only that part a stream. But so you can have as much calculations as you want. Now for each ordered is going to be the last thing anyway. So by using for each ordered, that gets most of the benefits of parallel streams. And this gives you the order of an ordinary stream. No, that's creation operator. You know, like the same as generate, iterate, whatever. Okay?
O'Byrne, Sheila Holland Fox, contact reception, Goronia O'Byrne or Sheila Holland Fox. Please contact reception. Thank you.
Right. So now we come to these fuckers. Okay, so the static void ex10. Static void ex10. Now, so this is ex10. And these are, so we've already done reductions. So the three reductions we did was min, max, and count. Now, there is another reduction, and this is called reduce. Okay? Now, so min reduces your list to just one output, so the lowest value. Max reduces your list to just one value, the highest value. Count reduces your stream to one value, the amount of items in your stream. Okay? Now, what the reduce method allows you to do is that this allows you to reduce your stream to any one type of object. Now, what do I mean by that? So, if you have a list of numbers, you can add up all the numbers and produce the sum. If you have a list of strings, you pick out all the English strings and you produce a sentence from that list of strings. Or you produce random letters, and using machine learning, you produce a coherent sentence. So reduce can be used in AI. Okay? It's whatever you have a stream of data and you want to reduce to one object output. Okay? You have another example. You have grandfathers, fathers, mothers, great grandfathers. All of their DNA produces you. Okay? So reduce, so whereas min does a very specific thing, max does a very specific thing, count does a very specific thing, reduce can be anything you want it to be. Okay? It can reduce your stream to a list. You can, it's awkward to do it to a list, but not gonna, there's nothing for doing that. It can produce a stream of objects to produce one object. You could use, let's say, a stream of people to produce an army. You could have a stream of cells to produce a individual. Okay, or you could have a stream of many different types of dog to produce the perfect dog. Okay, so it's taking a whole host of data and reducing it to one thing. All right, and it can be anything you want. Now, so whereas it's easy to explain, Jesus, the methods are not easy. Okay, now there is three overloaded. Now, most methods of the stream class aren't overloaded, but reduce is. Okay, so there are three overloaded reduce methods. Do you need to know them? Well, they're in the book. So if they're in the book, I guess you need to know them. Yep, 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 it is. Okay, which is why some of the methods look very complicated. Okay, so there are so comment. So there's three overloaded methods. Okay, so the first one is it has a reduce of type T. It's called reduce, and it takes an identity. Now this is usually a starting value. Okay, and it takes a binary operator of type T, and this is called an accumulator. Okay, so what's a binary operator? A binary operator, it takes two objects of the same type and returns one object of the same type. Okay, so this situation here, if we set T to be an integer, so it starts off with an integer. Okay, then it has a binary operator, and what does that do? That takes in two integers. I do that again. Okay, now we'll say T is a string. Okay, so it returns the whole method itself. Sorry, I should say this as well. Okay, so it has type T. It's returned, so let's say T is a string. Okay, so it returns a string. Method is called reduce. It takes as its first variable a string, and then it takes a binary operator which is going to have two strings, str and str2, and it's going to return a string. Okay, so it's going to return, let's say, str plus str2. In actual fact, the first one we're going to do is that one. Okay, so it starts off with a blank string, and then all the strings that are in your stream, it's going to concatenate them all together to produce a sentence. Yes, that's one example. If you had them all as integers, Okay, so you'd have integer, it returns an integer, reduce. It's going to start off with the number 0. It's going to take two numbers, so I'll call in1, in2. And what's it going to return? It's going to return in1 plus in2. So what is that doing? Total them up. Okay, starts off at 0, and it's going to add each one of the numbers. All right, now that's one reduce method. Okay, so I'll just type what this one is. So this returns a object of type t and takes as its parameter it takes two parameters. First parameter is an object of type t and a binary operator, and binary operator takes two objects of the same type t and returns one object of type t. Okay, so an example of that would be let's say I go stream integer. Okay, int stream is equal to, now we'll say stream dot generate produces a certain amount of integers, and we limit it to 10. Yeah, everything so far? Yes, I'm not generating at the moment now because I haven't fully worked this out. So stream dot generate dot limit 10. Okay, so then I go dot reduce. So that means that it would start off with 0. Okay, and then we would have a binary operator. We'd have in1, in2, and then we would go in1 plus in2. Okay, now so this reduce, the type t would be an integer. Okay, so what it would do, it would add up all your numbers. Now you could use a loop to do that if you want as well, but you can do it all here as well. Now you can do any sort of calculation inside here as well. It can be as complex or it can be as easy as you want it to be. So what does that produce? That will produce, now we will be doing this, we probably won't get to it today. Now that's the first type of reduce. Now the second type of overloaded reduce is actually a bit easier. It's this one. So this is, yeah. Well, no, that's not declaring the type, okay? Because the type is already declared here. Basically it, yeah. So it starts off 0 becomes in1. Okay, really that's starting position. So you start off at 0. Okay, now the other type of reduce, so this is the first overloaded reduce. I'm only going to do the first two to show you. I'm not going to show you the third one until tomorrow, because now is not the time to show you the third one. Because the second one is easy enough. Second, overload it, reduce. So it's got different parameter list. So it is a lot simpler. Now it does have an optional. Okay. An optional of type T, and it reduce, and it quite simply just has a binary operator. T accumulator. So again, we're going to add up our streams. So if we go in stream, so what's this? This returns a optional object of type T and takes only one parameter, which is a binary operator, takes in two objects of type T and returns one object of type T. Now I'll actually do out this one. So I'm going to do a stream of integers. And I'm going to call it int stream is equal to stream dot generate. I'm going to iterate to hell. Okay, stream dot iterate. I'm going to start off at 1, and it takes in a integer, and it multiplies that by 10, and limit it to 5. Okay, so all different lines. And then I'm going to reduce. And I'm going to take the simplest one, which is that one. Reduce. I am going to go in 1, in 2, in 1, plus in 2. Okay, what have I done wrong there? Okay, that. Oh yeah, that go in there. No. Give me a second here and have a look at it. Reduce. Hold on. Why isn't it? Takes in 2. Oh yeah, sorry. That produces an integer. Okay, that produces an integer. An optional integer. So it's optional integer opt int. Okay, so that produces an optional integer. Now, and so on the next line, then I'm going to go opt int or else get, that's a 0. Dot get bucket. We'll leave it like that for now, right? So this is now I'm going to check this as well. Peak consumer. Now, peak, this is a new one. Okay, now this is an intermediate operator. I'm just introducing it a bit earlier. Now, peak allows us to do exactly as it says in the tin. So I'm producing 5 numbers. Okay, so the first number is going to be 10. The second number is going to be 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, that should be the numbers that are being produced. Okay, and then it's going to add all those numbers up. It should get us, I don't know what it's going to get us. Okay, so I'm going to print that out. At EX10. Yep. Well, don't worry if you don't understand it now. We'll go through it tomorrow in detail. Just want to get one done before. So there's all our numbers: 1, 10, 100, 1,000, 10,000, which gives us 11,111, which is correct. Okay, that is the right answer. Now, if you don't understand that, fine, I will explain it tomorrow. That is the second overloaded reduce, which is the easiest reduce. The first overloaded reduce is probably the second most difficult one, and the third overloaded reduce is a pain in the arse. Okay, the third overloaded reduce takes I'll just briefly say what it takes. It takes a object of type t. It takes a bifunction object. It takes a binary operator. So it takes an object of type t. It takes a bifunction of type t. It takes a binary operator of type t. It's probably the most difficult method of the whole lot of them. All right. So what does that do? That adds up that multiplies all our numbers by each other. Sorry, no, it adds up all our numbers. So 1, 10, 100, 1,000, 100,000. Okay, and you can do anything you want with those numbers. Get the average of them, whatever you want to do. Okay, that's us finished for today. Stop the share. I'm going to finish the video. I'm going to process the video. So chill out for the next 10-15 minutes and then you can